Today's video is about complex numbers. So first we need to know what is a complex number, and in order to discuss complex numbers we need to define a new number. The new number that we're going to define is the number I. And you'll notice I put a little loop on my I because I don't want it to look like the number 1. I is defined to be the square root of -1, so that I squared is -1. So previously we said that you couldn't square a number and get a negative, but with this new number called the imaginary unit, we can. I is the number that when squared will give you a negative number. So now when we want to take the square root of a negative number, like the square root of -25, we can think of that as -1 times 25, and the -1 will come out of the radical as an I, and we'll get 5i. Similarly, the square root of -100, 10i. The square root of -32 we might want to think of as -16 times 2, or 4i, that's the square root of -16 times the square root of 2. So this is how we use imaginary numbers. Keep in mind when we had our rule earlier that said the square root of a times the square root of b was the square root of a times b, we did say that a and b had to be both positive numbers, greater than 0. So when we have something like the square root of -6 times the square root of, let's say -6 again, we can't multiply these together right now. We would need to make it I square root of 6 times I square root of 6. I times I will give us I squared. This will give us the square root of 36, and we get -6. I squared is -1, and the square root of 36 is 6. So what you want to remember here is you have to take the i's out first. If you don't do that, then you'll actually lose this negative sign. So a complex number is a number of the form a plus bi. We call a the real part and b the imaginary part, and a and b have to both be real numbers. So you might say 3 plus 7i, or 2 minus I radical 5. These are both complex numbers. And just as a side note, the number 3 is a complex number because it's 3 plus 0i. So anytime we have a new number set, like complex numbers, we would like to be able to add, subtract, multiply, and divide these numbers. So we're going to start with addition and subtraction. When I have two numbers like 3 plus 4i added to 7 minus 6i, basically, in this particular case, these parentheses don't mean anything. they're just separating these two numbers. We're just going to add like terms. So 3 plus 7 is going to give us 10, and 4i minus 6i is minus 2i. With subtraction, on the other hand, those parentheses are going to mean something. So the first thing we have to do is distribute our negative sign through our set of parentheses. And we'll get 3 minus 6i minus 5 plus 4i. And then we do the same as above. 3 minus 5 will give us negative 2. Minus 6i plus 4i is minus 2i. Addition and subtraction, we just want to remember to add like terms, and we can treat that I like a variable. Multiplication, all we want to be able to do here is distribute, and we want to replace I squared with negative 1. So for example, if I have 2x, let's say 2i times 3 minus 5i. We're going to distribute our 2i through, and we're going to get 6i minus 10i squared. And then we're going to replace our I squared with its equivalent, minus 1, and we'll end up with 10 plus 6i. If I want to multiply two complex numbers that are both binomials, 2 minus 4i times 3 plus 8i, for example, then we're going to do what you probably want to do, which is FOIL. So we're going to start by distributing the 2 through, and we'll get 6 minus 16i. That's the firsts and the outsides. Then we'll do the insides, minus 12i, and the lasts, minus 32i squared. If I collect like terms here, I get minus 28i minus 32 times, and we're going to replace that I squared with negative 1. So we're going to have 6 minus 28i plus 32, or 38 minus 28i. And I should just mention that it is convention to write the real part before the imaginary part, so your i's will always be second. That's multiplication. We also want to think about powers of I. So when we look at powers of I, we know that I is just I, and we know that I squared is negative 1. Those two we have by the definition. I cubed, if we think about it, is I squared times I, which is negative 1 times I, or negative I. And I to the fourth is I squared times I squared. Negative 1 times negative 1 will give us 1. After I to the fourth, if I go I to the fifth, I'll be back up here at I. So what we want to be able to do is use this fact when we have an I, and any power of I. For example, if I have I to the 18th, I want to take the number 18 and divide by 4. 4 times 4 will give me 16, and the remainder is 2. So this remainder tells me that this is equivalent to I squared, which we know to be -1. So essentially what I've done there is I've taken this 18 and I've written as, let me make this I to the 18th. I've written it as I to the 4th, I to the 4th, I to the 4th, I to the 4th. That's 16 of them, and 2 more. So remember, here this is 1 times 1 times 1 times 1, so those really are of no consequence to me. The result is this remainder I squared, which is -1. So as another example, we could do I to the 23rd. So again, we're going to take 23 and we're going to divide by 4, which is 5, with a remainder of 3. So I to the 23rd is going to be the same as I cubed, which is -I. The last thing